Okay, good morning, everyone. Good afternoon, everyone. All right, so today we are starting with our memo discussion for the past question paper for geography, which is term 2. Remember, term 2, we have, term 2, we have 35, that is term 1's work, and then the 40, which is term 2, right? So the term 1 is what is map skills, and then term 2 is theory. So let's start with our section A, which is terms 1 mark. We have maps and atlases. Identify the following types of scales. We have A and B. Okay, when you look at this, A is a line scale. It's in form of a line, and then 1 to 25,000. This is a ratio. Is a ratio scale. Then define the term scale. When you talk about scale refers to the ratio or it's a relationship between distance on a map and corresponding distances on the Earth's surface. All right, so you can say scale refers to the relationship. Scale refers to the relationship between a distance on a map and the corresponding distance on the actual ground. Okay, then we have compare a small and a large scale. When you talk about a small scale map, it covers a large area with less details. Small scale covers a large area, like the map of the world. A large area with less details. Then you talk about while a large scale covers a smaller area, like a map of a town, covers a large area, covers a small area with more details. Okay. Let's move on. Kind of scales in the atlas. All right. We have kind of scale in the atlas. We have the map given to us here. Refer to the maps above and indicate whether they are local, region, or world. All right. So we have map A. When you talk about, okay, this is map A. This is map A. It's the map of the map of Africa. Map B is the map of the province. And then this is a city map. All right. So when you look at map A is a world map. Okay, you can refer to it as a world map. And then B is regional map. And then C is a local map. Okay. So we have basically the extracts to 2630 AC and AD Howick topographic map and answer the following questions. When you look at this, when you see this 1:50 ratio, that is a topographic map. We are going to calculate the distance from H to G in the kilometers. Show all calculations. So we have our distance from A to H to G. All right, meaning we are calculating from here. Use a ruler, place your ruler here and here, and then you give me, and you get the centimeters. So when you press the ruler from H to G, our centimeters, we first say the distance on the ground. Distance on the ground equals to distance on a map times the scale. So those are the centimeters. So here, when you calculate, when you measure from H to G, our centimeters are 6,75 centimeters. Then you times them. Okay, on a topographic map, if you're measuring in meters, you times by, the scale will be 500. If you're measuring in centimeters, the scale will be 0,5. Then here, since it's in, sorry, if you're in kilometers, all right. So here, since it's in kilometers, we just times by 0.5 because it is the ratio scale. Then our answer using a calculator will be 135 kilometers. All right, convert the scale map to word scale. All right, so here we are going to see, we are going to say the map, the scale map, which is in, it's a ratio scale of 1 to 50,000. So here we shall say 1 unit or 1 centimeter, 1 centimeter on a map represents 50,000. This 50 represents 50,000. Or you can say 50,000 units on the ground. On the ground. You can call them units or centimeters. All right, so we have the global and satellite images. All right, we have the Earth's revolution around the sun. Study the diagram below showing the Earth's revolution around the sun and answer the following questions. You're going to study this diagram. What is the difference between the Earth's revolution and rotation? When you talk about rotation, rotation causes the cycle of the day and night. Okay, with rotation causes the cycle of day and night as different parts of Earth rotate towards the sun. They experience daylight while the opposite side experiences night time. You get your 2 marks. Then you say revolution causes the changing seasons, the tilt of Earth's axis on the revolution path means different parts of the planet receive varying amounts of sunlight throughout the year. throughout the year, leading to seasonal variations. Okay. If Earth's orbits were perfectly circular, would we still have seasons? Why or why not? All right. Here we can say yes. Our response is yes. Even if Earth, even if Earth's orbit were perfectly circular, the tilt of the tilt of its axis would still cause the seasonal variations in sunlight and temperature experience. Okay. Those are two. And then the other one you can talk about Earth's orbit. Where perfectly circular, we would still have seasonal changes. Seasons are primarily caused by the tilt of the Earth's axis relative to its orbit around the sun rather than by the shape of the orbit itself. Right, the world zones and time zones. Okay, let's move on to the world zones and time zones. What are world zones? Okay, when you talk about world zones, these are divisions of the Earth's surface. These are divisions of the Earth's surface into 24 segments, each representing a different standard time. Okay, then you'll need to schedule a virtual team meeting with participants from New York, London, Tokyo, and Sydney. Develop a plan for scheduling the meeting that accommodates participants from all time zones. Right. Here we need to choose a time that overlaps with the work hours of all participants. What you have to do is to choose a time that overlaps with the work hours of all participants. Then after, you need to aim for a time, slot that falls within the country. Sorry, that falls within the common. That falls within the common working hours for most participants to ensure maximum attendance. Here we have the satellite images. Refer to the satellite image below and answer the following questions. All right, we have what is a satellite image? And give an example. A satellite image is a picture of the Earth's surface captured by a satellite orbiting the Earth. All right. Is a picture of the Earth's surface captured by a satellite. Captured by satellite orbiting the Earth. These images are produced using sensors aboard the satellite. For example, you can give, e.g., you can give the Landsat. You can give the Terra and Aquia. Okay. All right. So you can also give an example of Meteosat satellites. Explain two ways in which satellite images are used by geographers. One, they provide a profile. They provide a profile, the ups and downs of the land, ups and downs of the land. Here they give us an understanding. They give us an understanding of the way in which land is used. Okay, they allow us to monitor the effects of man-made and natural disasters. Climate regions. All right, we're going to section B, which is about climate regions, factors that influence temperature and rainfall. All right, we have mentioned 4 factors influencing temperature and precipitation of an area. All right. Here we have the factors. We have latitude. You can talk about latitude. You can talk about altitude. You can talk about ocean currents. You can talk about mountain ranges. You can talk about prevailing winds. You can talk about prevailing winds. So you can give any form. Where will the temperature be higher? Area A or B? Give the reason. The temperature will be higher in area. It will be in area A. Why? Solar energy is concentrated on a small area. How is rainfall formed in equatorial regions? Okay. How? Equatorial areas are warmer, heated. Equatorial areas are warmer, heated, and moisture laden. Air rises and cools, forming clouds and rainfall. All right, we have 3.2.1. Choose the correct word by underlining. Ocean currents that come from the equator, are they cold, warm? These ones are warm. And here, they are cold. What is the difference between maritime climate and continental climate? Maritime refers to coastal areas with a small difference between the max summer temperature and mean winter temperature. Then when you talk about continental climate, continental refers to inland areas with a big difference between the summer and winter temperature. Indicate whether Cape Town will experience a continental or maritime climate. Motivate your answer. Cape Town will experience a maritime because there is small difference between the summer and winter temperature. Okay, then we have explain why places at the east coast of South Africa are experiencing high rainfall. We talk about the warm Mozambique current increase the water body stroke ocean, therefore warm moist air rises and causing a high rain to fall at places on the east coast. Okay. Refer to the climate chart of South Africa, cities showing rainfall and temperatures as the following questions. Let's go to 4.1.1. In which season do Cape Town and Johannesburg receive the highest rainfall? Respectively, Cape Town receives in winter, Johannesburg receives in summer. Then, okay, we have, according to the graphs, in which month do both cities experience the lowest temperatures and how much? All right, in which months? That is June. And then in which months? It's also June. All right, elements of weather define weather and climate. Weather refers to atmospheric weather, refers to atmospheric conditions of a place over a short period of time, while climate is the average weather of a place over a long period of time. Describe the two elements of weather. We can give temperature. Temperature, you can say how hot or cold air is. Then humidity, the amount of water vapor in the air. Water vapor in the air. You can talk about wind speed, how fast the wind is blowing. Okay, you can talk about wind direction. Direction from which the wind is blowing. And then we can talk about precipitation, that is condensed water vapor, condensed water vapor that falls to the ground. as rain, hail, and snow or sleet. All right, then we have altitude. Say the photograph below showing Mountain Kilimanjaro. It lies near the border between Tanzania and Kenya, almost on the equator. However, Mount Kilimanjaro always has snow on its summit. Explain by writing a paragraph why it is so cold at the top of the mountain. All right. So we say while Mount Kilimanjaro, Mount Kilimanjaro lies near the equator and receives strong sunlight. The reason for snow kept summit lies in the principle of decreasing temperature with altitude. Okay, then we can also say as you ascend, the mountain, the air thins, leading to a significant drop in air pressure. Okay, we have this decrease in pressure. This decrease in pressure directly affects air temperature. Causing it to plummet. Okay, then we can say this rapid temperature drop combined with the high altitude of Kilimanjaro. Kilimanjaro's peak creates conditions cold enough for snow to accumulate and persist year round despite the mountain's equatorial location. Okay, so that is it. We have covered section A and section B. So our paper is out of 75 minutes.